This is Mr. Powers. I am most likely having a baby right now because it's Monday and you're watching this. So I want to make sure that you don't fall behind this week, and some of the things that we'll be doing will be these video lessons to help you stay caught up and that we can kind of go through the material in the same way that we would do if I was here, just to make sure that no one falls behind. So the first thing that I want to discuss is you should have just developed 3 rules with the class, and the 3 rules are that like charges repel each other, opposite charges attract each other, and neutral objects can be attracted to either positive or negative things. And so before we begin with the simulator, I want to talk a little bit about the fact of what neutral means. A lot of times people misinterpret neutral to mean no charge, and even neutrons, they say like no charge. Neutrons have charge, and neutral objects have charge. There's charged particles inside these neutral things. What all that means is that the charges are balanced. So here we see a neutral sweater, a neutral balloon, and a neutral wall, because all of the nucleuses, the positively charged nucleuses, are balanced by the electrons, the little negative charges on the outside of those atoms. So the way the simulator does this, it's a really simplified way of showing the atom with just a plus sign and a minus sign, but that's pretty much what we think of when we're talking about these charged particles in the atom, is a dense, positively charged nucleus with as many electrons surrounding it as there are protons inside of it. And normally things are balanced. Some materials can take on additional electrons. And one thing you'll see in this is that electrons, these little blue minus signs, are the only things that will move in the simulation. We tend to only think of the electrons as the things that are able to move and the things that are flowing through wires because they're loose, they're on the outsides of the atom. The nucleuses are full of these positive protons and neutral neutrons, and they are stuck, so they don't move. So when you talk about charge movement, it's really the electrons that are moving around and getting sent back and forth. So if we take this balloon that's neutral and rub it on this other neutral object, this will be a lot like what we did with 2 pieces of neutral tape. When we did this, we ended up making one tape negative and one tape positive, and now I have a negatively charged balloon that really wants to go towards that positively charged sweater. If I just show the charge differences, all we have is negatives in the balloon, positives in the sweater. But this negative balloon can also be attracted to this neutral wall, and to show what's happening there, let's turn back on the charges. The wall is balanced, but when I bring all this excess negative charge near these minuses in the wall, you can see them start to behave where they're trying to get far away from that as possible. And so as those minuses start to try to get away, it leaves this positive edge on the side of the wall. So the electrons don't leave, they're just what's called polarized. They're just getting as far away from the balloon as possible, and this creates this charge by polarization. The wall has this induced charge, it's kind of temporary, and as this positive edge here is attracted to these negative charges here, we get the balloon to stick. So right now I'd say the sweater's overall positively charged, the balloon is overall negatively charged. The wall is still neutral, but we can still get this attraction from a neutral object and a negative charge object through this process of polarization. Alright, so I have switched over to a new simulator to help show this idea of how positive tape and negative tape can actually do the same thing to a neutral object. I have an aluminum can here. It's neutral to begin with. The total number of electrons would equal the total number of protons in this material, so it's not charged up one way or the other. If I bring in a rubber rod, this aluminum can is attracted to rubber that is negatively charged. What we would do is rub this rubber rod with like a cloth, and it would take on additional electrons, very much like the balloon took on additional electrons from a wool cloth. But a glass rod would actually do the opposite. If you rubbed a glass rod with a wool cloth, it would actually donate electrons, and so this positive one can actually do the same thing where it attracts. So this is like The positive tape would attract it, or the negative tape would attract those neutral foil or neutral pieces of paper. So how is that able to happen? If we show the charges in there, you can see what's happening. All the negatives are stacking right on top of their positives, so it looks like it's overall negatively charged, but really these are just balanced. If I bring in the rubber rod again, you can see the negatives try to get as far away as possible because like charges repel. And the positives don't have the ability to move. So what's happening is the negatives are trying to get as far away as possible. You see they're all lined up on that opposite edge. And when they do that, that leaves this positive edge exposed. So like charges attract, and you get this attraction between the rod and the aluminum can. This would be like the bottom tape coming near the foil or the paper, and you were able to induce this polarization in the material that allowed it to attract. Well, we can do the same thing. Let me take off the rubber rod, and you see how all the atoms go back to being balanced. If we bring in a glass rod that's positively charged, we get kind of the opposite effect where the negative charges now want to be near this positively charged object, and again, they have the ability to move, so they try to get as close as possible. These positives aren't leaving, they can't really escape, they're just kind of stuck in the material, but it does leave this positive edge over on this side and a negative edge on this side, and that's how that is still able to attract the object. Whether it's a positive charged object or a negatively charged object, we get this polarized effect.